Hello, today's lesson is all about solving equations, and although you can sometimes do these in your head, especially when they are math facts you're familiar with, today's lesson is going to show you the strategy of using inverse operations. So the word inverse is the first thing we have to discover, and inverse is just a fancy math way of saying the opposite. So the inverse operation is the opposite of whatever operation you see happening. So if you see addition, the inverse or opposite of that is subtraction. The inverse of subtraction would be addition. The inverse of multiplication is division, and the inverse of division is multiplication. So keeping that in mind, we're going to dive into some really simple one-step equations with an unknown variable that we can solve using inverse operations. You'll notice that we're going to solve just one of each type of operation. So right over here, I see addition happening, subtraction is over here, multiplication is down here. Even though it's really hard to see, we know that in math, when things are stuck together, that meant that they were multiplied. And over here, we see division. So I'm going to show you my strategy, and I call it the upside down T method. This little upside down T chart that we're going to draw is sometimes a really magical step that helps people organize their thinking. So I'm going to start at the equal sign of whatever my equation is, and I'm going to draw a little upside down T chart. And what that does is it just helps me keep things on the right side of the equation. So I'm going to look over here, and I notice that I'm solving for the letter T. So in order to isolate my variable, in order to get that T all alone, I need to use the inverse operation. So instead of adding 41 like I have, I'm going to do the inverse. So I want to subtract 41 from this side. And the reason that I want to do this is because the opposite of adding 41 to something would be to take that 41 away. And so if I add something in real life and then I take it away, it's like it never happened. We call that canceling themselves out. If I subtract 41 from this side of the equation, I'm going to go over here to the other side of the T, and I'm going to subtract 41 from this side as well. I also personally like to cross off the parts of the equation that were perfect inverses of one another. So adding 41 and then taking it away, those cancel each other out because they were perfectly opposite to one another. And now what I notice is over here I have a mathematical expression to solve. So 82 minus 41, 2 minus 1 is 1, 8 minus 4 is 4. And for my final step, all I need to do is take anything that is still remaining in my equation and bring it down to my answer. I still have an equal sign, and I still have the variable t, and I'm going to circle my answer. T equals 41. Some people could have definitely done that mental math, but this is a really good strategy to practice now so that it's there when you need it. Over here we have the equation b minus 13 equals 97. I'm going to do the same strategy again. I like my upside down T-chart to keep myself organized. Notice over here we have the variable b that we're solving for, and what's happening to it right now is we're subtracting 13. To undo that action, or the inverse of that action, is to add 13 back. If I add it on this side of the equation, I'm going to add it on this side of the equation. I like to cancel out my perfectly inverse pieces. And then I'm going to do 97 plus 13 over here. So 97, 7 plus 3 is 10, and 9 plus 1 is 10, plus another one is 11. I got 110. I'm going to bring down my equals, and the 13s were gone since we used inverse operations, so I just have a letter B. My answer is B equals 110. This same strategy also works for other operations. So we have multiplication and division to try these out on next. So over here, I like to put a little multiplication dot in here just because I know that that's really helpful for some people to see that there's actually some multiplication happening over here. I'm going to get my upside down T-chart ready. Instead of 12 times d, I want the inverse. The opposite, or the inverse of multiplication, is division, and I'm going to draw it with a division line because as sixth graders, we know that that's the best way to draw it moving forward. So we're going to divide by 12 over here. If we divide by 12 on that side, I want to divide by 12 on this side as well. So these 12s canceled each other out because they were perfectly opposite of one another. They were inverses. Over here we have 48 divided by 12. I know with my math facts that the answer to that is 4. So I'm going to bring down 4, I'm going to bring down my equal sign, and I'm going to bring down the variable d. So my answer is 4 equals d. Last but not least, I'm going to draw my upside down t-chart on this side as well. Notice that to this variable f, we are dividing by 9. The inverse of that is multiplying by 9. I can write it off to the side. Some people like to see it there. Or if I'm using my t-chart, you can just show it down in the t-chart as well, times 9. We're going to multiply by 9 on this side as well. My 9s cancel out. And now over here, I have to do 18 times 9. 9 times 8 is 72. Regroup the 7. 9 times 1 is 9 plus 7 is 16. So I got an answer of 162 equals F. And if I were to plug that back in, if I do 162 divided by 9, it will give me the answer of 18. Here's some examples I want us to try together. So make sure you give yourself some time to either pause and write these down or go to the document I shared with you and print it out so you're prepared. The first thing I'm going to recommend is for 1 through 6 is go and get your upside down t-charts completely ready before you begin. Sometimes setting things up like this can really save yourself some time later. So I now know that I have 6 problems set up and ready to go before I even dive into the math. Okay, we need to be thinking of inverse operations. So over here I see an x plus a 7. The inverse is minus 7, and I'm going to do that from both sides. The 7s cancel out. 23 minus 7, you can either do it the traditional way and regroup. I'm just going to put 23 in my head. I'm going to count down 7, and my answer is 16 equals x. Okay. Number 2, I see x minus 8. The inverse is plus 8. We need to do that to both sides. The 8s have now canceled each other out, and now we have 15 plus 8, which is 23. Equals x. Okay. Number 3, we see x plus 2. The inverse of that is to subtract 2 from both sides, and we get x equals 8. Number 4, I see a minus 3, so I'm going to add 3. That's the inverse. My answer is a. 13 plus 3 is 16. Next, I see 23 plus y, so I need to take away 23 from both sides. So I've got some regrouping to do here if I'm doing this the traditional way. So this becomes a 3 and a 12. 12 minus 3 is 9, and 3 minus 2 is 1. I got 19 for my answer. These 23s canceled out. So I'm going to write y equals 19 and circle my answer. And lastly, I have c minus 3. I'm going to add 3 to both sides. My 3's canceled out. 9 plus 3 is 12. So my final answer is c equals 12. Now we're going to extend this just a little bit to show that, in fact, it does work with multiplication and division. 7 times q is 49. I'm going to get my t-chart ready. The opposite of multiplying by 7, we can see that multiplication happening, if you want to add that dot there, is divide by 7. So we're going to divide by 7. My 7s cancel out. 49 divided by 7 is 7. So my final answer is q equals 7. And last but not least, it works with division as well. So over here we have r divided by 5. The inverse of that is to multiply by 5. We're going to do that on both sides. The 5's cancel out. So 7 times 5 is 35 equals r. And there you have solving using inverse operations. Thanks for tuning in today. I hope this brought all of that math that we've been working on back to your brain, and it is time for you to go and practice on your own. Good luck.